The Euler forward method is a fairly simple method for approximation of an initial value problem. Given a function f and an initial value of y0, we can calculate the initial slope. By choosing an appropriate step size h, we can approximate a value for y1 by multiplying against the slope at point y0. The fourth order Runge-Kutta method approximates the solution to initial value problem by estimating the slope 4 times over the same time interval. There are a couple variations on the fourth order method, but if you look at the one used in the textbook, the estimated slopes in this variation are K1, calculated at the beginning of the time step, K2, calculated at the midpoint of the time step using K1, K3 at the midpoint, calculated using K2, and K4 at the end of the time step. Although the formula used in the textbook multiplies all these estimates by the same value, some variations prefer weighting the slopes differently, depending on what we expect to be a better estimate. The Euler forward method is a good basic method for introducing students to solutions of initial value problems for ordinary differential equations, and it serves as the basis for more complex methods. But because it's based only on the calculation of one slope at the beginning of the time interval, it tends to deviate greatly at larger values of h, and it can actually become unstable for even non-stiff equations. The fourth order Runge-Kutta is a more accurate method because it estimates the slope across the entirety of the time interval. However, it may take more computing power to do since it involves extra steps. To really drive the point home, we can look at the accumulated errors for these methods. The accumulated error, or global truncation error, for Euler is on the order of the time step h, while the global truncation error for the Runge-Kutta method is on the order of h to the fourth, which means that for a time step of, say, 0.1, Euler's method has an accumulated error proportional to 0.1, while the Runge-Kutta is proportional to 0.0001, which is a pretty massive difference.